The same part through inspection reports, but through completely different conclusions. One report shows out of tolerance, the other says it passes. If the part hasn't changed, where did the difference come from? When it comes to precision manufacturing, inspection is not simply about data. Equipment accuracy is only the foundation. The real key is the inspection approach. Today, we'll look at the 3 real cases and see how different inspection methods can affect the final conclusions. Let's start with a small example, this position ring part. When checking parallelism, many people will simply place part flat on the inspection table. It looks like the right way to measure, but actually this can create measurement error. No matter how precise the table is, it still has a tiny uneven spot. When the part directly contacts the table, this small deviation may affect the measurement results. To avoid this, we use a dedicated feature to hold the part vertically. Then we calculate the measurement point again. By changing the inspection setup, we remove the inflation from the table surface and get a more reliable result. Then we move to the different situations throughout the hole position inspection. For assembly parts, hole position accuracy is critical. It directly affects where the parts can be assembled smoothly later, but the threads are not ideal for direct measurement. The thread has a helix shape, is discontinuous, and has an angle. When a purple touches the thread directly, it can easily introduce the measurement deviation. To solve this, we use a 2-step revocation method. First, before stepping, we inspect the position of the pilot hole. This gives us the most accurate position reference. Then, after tapping, we perform a second check on the finished part. One step locks the true position, the other verifies the final result. By combining these 2 steps, we cross-check the data. This reduces accumulated error and it ensures stable and reliable assembly performance. Besides the inspection method, datum selection also affects the results. For this stepped ring parts, several key features require tight position control. In the original drawing, datum B was defined on the outer face, but after evaluation, we found an issue. The surface needs polishing. That means the inspection datum and the final functional surface may not match. In the later discussion, we also consider using the inner deep hole as a datum. Practically, it is possible, but in practice, it requires multiple setups to measure all features. And every reprocessing step can add more measurement variation. So during the early design review stage, we suggest moving datum B to the bottom step surface. Now, all key features can be measured in one setup. This improves efficiency and it also reduces variation caused by repeated positioning. For high precision parts, many quality issues are not discovered during inspection, are actually improved much earlier in the design and process review stage. So to wrap it up, from inspection setup optimization to dual verification and datum improvement, we don't just provide inspection, we provide proven engineering solutions. If you need a more reliable solution for high precision parts, feel free to contact WayKen. See you next time.